Thank you, Sabu. Thank you very much for another opportunity to speak to you. Uh, Today's topic is very India specific. Today's topic is India specific and this decade specific. That is from now till 2030. What are the most important technologies which India need to imbibe, need to apply, need to execute, and start seeing the results of all those efforts by end of this decade. So I have a presentation to upload. So I'll just upload that. Are you able to see my presentation?
Yes, sir. Yes.
Okay, right. So I'll straight away start. All of us know that we are already the fifth largest economy, and the government has some plans to make India the third largest economy by end of this decade. So obviously, this would require some initiatives on the economic front as well as on the industrial front. And many of these are going to be achieved through new technologies. I'm going to capture those aspects today. What are the technologies which we need to embark upon, which we are not doing now in adequate measure, which we need to embark upon to achieve this target? The current decade is also very challenging, not only because we want to become the third largest economy, we also have to achieve it by controlling carbon emission. So there is a dual aspect in this challenge. One is achieving economic prowess, and other is controlling carbon emission along with it. So we are looking at new areas where resources will come from. And towards that, there are some very important programs which are on the anvil. I've briefly touched upon as seabed and semiconductor manufacture. I will go ahead in my subsequent slides on this. For all this to happen by 2030, that means all those targets for carbon emission as well as third largest economy, it is definitely important that we imbibe these technologies. So I got 8 technologies listed today, and I will go through each one of them for 2 to 3 minutes each. And I won't be able to go into great detail on each technology. So if you've got any questions, we can do it during Q&A period. So I'll go to the first one, which is sea mining technology. It is not happening now. First thing, sea mining is not being done in India or in any country because the approval for doing this has not been given internationally. It is supposed to be given by UNO through a special organization called International Seabed Authority. It has not happened till now, but it is expected to come very, very soon. However, in anticipation of this sanction coming sometime by end of 24, different countries have started doing their research and development, doing their preliminary trials, etc. India is one of the countries which has gone ahead and done the preliminary trials. So this is India's map. Can you see this dotted line all around India? That is India's economic exclusive zone. So any mineral wealth lying within this dotted line belongs to India. India is also trying to get additional area in this hatched area on the western side as well as the eastern side. That case is pending with UNO. But otherwise, the dotted line encompasses the area where mineral wealth and other resources are definitely ours. Only thing is you cannot start doing commercial production. You cannot do extensive removal of resources till UNO's ISBA gives the approval. One more point I want to add, the total area in the sea is very close to the total area in land. But if you get these additional areas which is marked on the east and the west, then you will have more area in the sea than in land. And we have started almost taking out minerals from land in a big way. Now we are looking towards the sea. Now this is how it will happen. There will be ships on top of the sea. Huge pipes will go down. There will be a machine which will pick up these deposits from the seabed. It will go through this pipe. In the ship, it will get removed, and the balance water or slurry or mud, etc., will come back to seabed. This is a technique used by most of the countries. India has already started doing it on a trial basis at 2 points in Indian Ocean, which has been given to us only for trials, and we are going ahead with that work. There's an organization called NIOT in Chennai, National Institute of Ocean Technologies, who's spearheading this activity, and they have gone ahead in the last 5-6 years and achieved a great amount of success in their trials, even at the depth of almost 5,000 meters. That means from the ship to the seabed, it's 5 kilometers. This is the type of machine which they lower from a ship, which will walk on the seabed without getting stuck in the mud due to special arrangement of on their propulsion, and they'll be able to do the survey, and the pictures will be seen on top before they are picked up by some other machine. The 2 points where we are permitted to do the trials are shown in the red dot. It is south of Sri Lanka, south of India, of course, and this is where we are doing our trials at this point of time. And what we get from down below, initially it comes like this. This will be brought to the land. It will go to some factory where it'll get refined, and you will get the metal which you are looking for. And what we are looking for is nickel, cobalt, manganese, etc., copper, etc. So a lot of wealth is lying there, and we have to consolidate this technology before we get the sanction from UNO, which will be a common sanction for all the countries having EEZ. So we should be ready to start in good measure by that time. So now I will do the next technology. The next technology is semiconductor manufacturing technology, which you have definitely read in the paper what is started. So I will just touch upon this. Semiconductor actually comes from sand, silicon dioxide, which is purified to get silicon. And once you get silicon, the other metal which is used is germanium, but we are not talking about it. There is always more of silicon. The molten silica is converted to shapes like this and then cut into small, small, thin wafers, which will be of different types of diameter. And this is one of the basic component used in semiconductor manufacture. And when you finish making wafer, you're crossed step 1. Now, the semiconductor wafer, which is normally circular in shape, on which some photolithography techniques are done, and you will get small squares called dice. Each will have something like 10,000 to 20,000 transistors, which will help you to make the hardware. So these squares are called dice, which are used for making a circuit. And this is step 2. When you make a die, you completed step 2. So step 1 is wafer, step 2 is dice. Step 3 is making an IC with all the dies interconnected as per logic, as per the circuit requirement, be it for a washing machine, or be it for a car, or be it for a satellite, or be it for a missile system. You make the design as per the requirement of the function which is supposed to be done. We are already doing design in India. Many companies are doing it. Tatas are doing it. There are other private companies are also doing it, like HCL. Then Mahindra's also started doing it. So we are doing almost 1,000 designs every year today. There have been 1,000 different types of integrated circuits we are designing in India. That is step 3. So once the design is completed, as per the requirement of the customer, here the customer is, as I told you, maybe a car company or a washing machine company or some music system company. Once you have designed the IC, then you take the dies as per the design, package it, wire it, and test it. That is step 4. So let me spend 1 more minute on this slide. There are 4 stages. Step 1, wafer. Step 2, making dies. Step 3 is design, which is done in a laboratory, in a design center. It is mostly done on a computer. And step 4 is assembling all these dies, required dies, interconnecting them, encapsulating them, putting them epoxy cover, and testing it with the software loaded in it. Today, India is doing only step 3. There is no step 1, there is no step 2, there is no step 4 today as we speak. But 10 days back, government has given a lot of money for Tata to start 2 companies, one in Gujarat and one in Assam. The Gujarat located company will do step 1 and 2. Tata is already doing step 3 in Pune. And the Assam company will do step 4. So the step 4 is a relatively simpler job. So we expect the Assam company to do step 4. We expect them to do serial production by next year. So by next year, we'll have step 4 in addition to step 3. And step 1 and 2 in the Gujarat company, Gujarat-based company, will start only by 26. So in another 3 years' time, or 27, in another 3 years' time, India's first IC manufacture will take place in full measure. That is step 1, 2, 3, 4, right? We can discuss more on this as we go along. Now, I need to tell you, why are semiconductors so important? They are definitely important because today everything is electronics. Electronics has to be compact. Electronics has to be software-based. Electronics has to be digital system. So you have the requirement of ICs, which are semiconductors. It is the value of semiconductors imported today is very close to the value of crude oil imported. Soon, we will expect that chips will overtake crude oil for 2 reasons. One, we require more chips. If you don't make in India, we'll have to buy. So we'll import more. That is number 1. Number 2, crude oil requirement is slowly coming down because renewable energy is coming up in a big way. So we will have, today we are almost importing $56 billion worth of chips. Idea is to make chips in the country, not all type of chips, some type of chips, I'll talk about it later, and reduce our imports. We have enough reserves of rare earth element, almost 6% of world's supply. So we have enough silicon available, enough sand available for this. But converting sand to silica for step 1 and later for step 2 requires a very mature ecosystem. So we will take some time to establish this facility in the country, which is so immediately required for the extensive digitalization which is happening for 5G communication, for defense, aerospace, etc. Now, once we make this, once we make step 1, 2, and 4, it will match with the 3, which we're already doing. So we'll have 1 plus 2 plus 3 plus 4, which will make sure that we are able to make Sand, from sand, we are able to make a chip, right? Government is giving a lot of support. Government has earmarked 76,000 crores as incentives. They fund the project cost almost to 50%, and the feasibility is examined by a big committee. So as far as the next technology which we saw was semiconductor manufacturing, which is already started in Gujarat and Assam. It has been inaugurated by the Prime Minister in the month of March, and we expect this to start immediately for step 4 by early 2025. And as far as 1+2 in Gujarat-based location, it will take 3 years' time. So that is my second technology which I have covered. The third one is thorium-based nuclear power. Why are we talking about this? I will tell you. Today, India has 23 reactors in India. They produce nearly 7 gigawatts of power. The other countries which are having more reactors and producing more power per reactor is shown there: USA, France, China, Russia, etc. Our country has fairly large number of reactors, but they are not producing high amount of power. And the growth in nuclear power sector has been much lower than the other countries. France, USA, China are all in leading position. The details are there on the slide. India is the 7th position. All the reactors put together in India, they produce less than 2% of power generated in India. Maximum power is generated by thermal power plant, very close to 60 plus, then wind, then solar, then wind, then hydro, then comes nuclear. So there's a need. Nuclear is clean and green energy. So there's need for us to produce more nuclear energy, but we are not able to do it. I'll tell you why we are not able to do it, due to 3 reasons: 1, 2, and 3. First thing is, we don't have enough uranium. Uranium is the basic fuel for nuclear reactor. So nuclear power reactor, uranium is available very limited in India. If you start using only Indian uranium, it will finish in the next 20 years. We can't do that. So we use little bit from India and more from imported from outside. And import is not easy because it's controlled by nuclear supply group. So there are a lot of international control on getting uranium. Or if you get uranium, you have to account for its utilization. You can't use it for enrichment for nuclear weapons. So there are a lot of checks and balances in this uranium supply. Second, India has lots of thorium, which is available in India in big measure, but we are not able to use thorium for nuclear reactor because nobody is using it, because thorium is not fissile. While uranium is fissile, you can have a fission reactor from uranium, but not from thorium. So we have a problem. We have thorium, which cannot be directly used. So how to do this is a question. At the same time, you desperately want nuclear power, which is clean and green, so that thermal power plant can be slowly shut down, which are producing a lot of carbon emission. As I told you, more than 60% is from thermal power stations. And a lot of carbon emission is from the thermal power plant. So if you want to control carbon emission, which is another challenge, another target which you have to achieve, which you are committed, then you have to enhance nuclear power. It's a must. So what is happening is, this photograph of Prime Minister visiting Kalpakkam last month was on the occasion when thorium has been put in a breeder reactor. So look at the diagram. There's a used thorium. That means this thorium has already been used. Half-life is over. That used uranium, which has been used in other reactors, is brought to a thorium-based fast breeder reactor. mixed with, uranium, uranium is brought to thorium-based reactor, plus thorium is also taken. Thorium and uranium are mixed together in the form, they put like a cake around the reactor control rods, and they are able to initiate fissile process by which power is made. This was conceptualized by Homi Bhabha 50 years back. They have been trying this, and every time they tried it, the fast breeder reactor consumes more power than it produces. So that is of no use. You should produce more power than what you consume. Then only there's net power available. I think they have been able to get some breakthrough. So this visit of Prime Minister is essentially for loading the new set of fuel. And it is expected by early 25, you will get some results of this thorium-based fast breeder reactor, and which is in Kalpakam, and you will get power. Once this is successful, almost 50, 60 such reactors will be installed in different places in India, and each reactor will provide some element of power, but they will be using only thorium along with used uranium. So you will not deplete our uranium stock. You will not get worried about importing uranium, but you will be using thorium. This technology of fast breeder reactor is one of the crucial technologies for India up to 2030. Next, I will go to artificial intelligence. This is something which many of you know, but I will quickly go through. That means when you have data coming in, it is processed the way the hierarchy is like this. It goes up to knowledge and wisdom and intuition. But intelligence is not this. Intelligence is, I'm talking of human intelligence now, not artificial intelligence. Human intelligence is when you have the knowledge on the subject and you're able to speak, you're able to write, you're able to communicate. So if you have both ability to speak, ability to understand and communicate, at the same time have knowledge, then you have human intelligence. A person who does not have knowledge, he may be good in speaking, he doesn't convey much. A person who has knowledge, but who cannot speak well, he also does not convey much. So you should have both knowledge and ability to speak. When you combine these two, you will say he's an intelligent man. It's different from a knowledgeable man. So an intelligent man will have both these traits. When you do this combination of ability to communicate and knowledge in a computer, it is called artificial intelligence. That means the human intelligence is replaced by a computer with some software written on it. And the data will be given to this computer. Inside the computer, it is able to compare this data with the trend, the previous values, the other parameters, etc., which will build up information. And based on that, it will have some knowledge generated. It will keep this knowledge in its memory, and it will apply its ability to put out the data, which will be in the form of voice. It can be an alarm, it can be a text, or it can be even a control of something to be switched off, something to be started. So this AI computer is something which is performing what happens in your brain, knowledge, and if you're able to speak, the ability to communicate. So both these are done by AI. Very simply I put it, just remember this. I'll give you some examples. Alexa, many of you know, that is a simple example. It is able to understand your voice and then do the function, switch off fan, switch on AC, whatever it is. And it's called a weak AI because that AI is not very complicated. But if you want a strong AI, it is a driverless car or Google Map, medical diagnosis using AI. That's all strong AIs. And if you want to generate a lot of information, text generated using Chat GPT, then it's called a generative AI. So AI is in three types: weak, strong, and generative. Just remember this. Recently, we had seen something. I don't know how many of noticed this. An AI tool called Bhashani was released by the government. Many of you would have seen the video where the Prime Minister spoke in Tamil. He spoke at Varanasi sometime in, I think, November, December. And he spoke to the crowd, which is consisting of a lot of Tamilian people. It was put in the music, in the public address system, and he was speaking in Hindi, but what came out was Tamil. The AI was translating his Hindi into Tamil, and that was going to the people. Of course, the voice which was coming in was a computer-based voice, so it was not based on the Prime Minister. The voice was what the computer was generating, just like Alexa was saying. So this AI tool called Bhashani has been released, and you may have seen the TV Prime Minister discussing with I forget the name of the person who had visited India, and he was with him. He was able to speak in Hindi, and the entire text was coming in on the computer screen. He was having discussion with him. So that is on AI, and AI is going to come in a big way. It is going to help you with various appliances at home. That will be all weak AI. It will be used for maintenance and logistics, but strong AIs will come in finance systems, driverless car, in agriculture for getting higher yields, and social media where precise demographic targets are done. Defense applications and healthcare, etc., will use strong AI. So you will see that AI will have lots of new projects, a lot of new products coming in the market, which will be not only ChatGPT, but also pertaining to strong versions of AI. And you will see some of it. We can discuss this during question answer session. The next topic is real-time data fusion. There are a few engineers in the audience. Notwithstanding that, I will go through this very slowly. It's a topic which is not commonly discussed. So let me explain this with little help of a little diagram. So assume there is a command center, in this case, a command military center, which is getting information from satellite. Some picture is coming from satellite. Let's say the picture is about Indo-Pakistan border, someplace it is sending the picture. The picture is also coming from a drone operating in that area, operated by the army, and that's also giving the picture of the same area. There's an aircraft which is operating by the Air Force in J&K area. It's also sending some picture. There are Jawans on the ground who are having mobiles, who are able to take video and are able to give pictures of any enemy movement. I will disregard the ship now because we are on land now at this point of time. So the satellite plus drone plus aircraft plus mobile data, how do you put the data together? Satellite has got its own clock. It gives data in GPS, latitude and longitude. Source drone, latitude, longitude. Similarly, aircraft, and you can get this from mobile also. But the time reference of all four need not be the same. Satellite has got a clock. Drone has also got a clock. Aircraft, your mobile also has got a time clock. But how to synchronize the clock? How to get data at the same time from four different sensors? Then only you can fuse it. There's 10 seconds delay between these two. Then when you fuse it, you're not giving the correct picture. They should correspond to the same time. Now, that is one challenge. The satellite has got a camera, which has got certain angular vision. Similarly, drone and aircraft and the mobile also. how to make sure the latitude, longitude, and the vision which is selected, which is angular vision selected, the GPS are matched and the time is matched. So you have to fuse the data in both time and position. This is a huge challenge. The same situation can be over the sea. Of course, the mobile may not be there. There'll be aircraft, there'll be drone, there'll be a ship and a satellite, and you have to fuse the data. Now, this has been done extensively in Russia-Ukraine war by Russia as well as Ukraine with the support of US, and it has been used extensively to get the correct picture on what is happening on the ground. From multiple sources, you fuse it. So towards that, inside the satellite, you have what's called a rubidium clock. India initially bought these clocks from abroad. It is an atomic clock, which has got high level of accuracy. Now India started making it, ISRO started making it. So the Navik satellites of ISRO, a Navik is a set of satellites which will replace GPS in a few years' time, maybe by 2030. So Navik satellites already got Rubik clock made in India. So what will happen is all the satellites of Navik, which will be supporting the defense forces tomorrow, and which will substitute the GPS, and therefore you don't have to worry about GPS will be switched off by USA, and our defense forces will not get the data. So what will happen is Navik will work on this Rubik clock, and that time signal will come to ground, and that will go to the aircraft. Before it takes off, it synchronizes, or the drone before it takes off, it is synchronized, or it will go to all mobiles in the country. So you will have common clock for the satellite, the drone, the aircraft, and even the mobile and the ships, which will enable your time fusion of data perfectly. So this is likely to happen in India maybe in the next 2-3 years. Attempts are being made by R&D agencies to generate this, and we will be able to, initially we will do with GPS latitude and longitude, because Navik has not started operating independently. And after a few years' time, when Navik comes in, GPS will be, data will be removed and Navik data will get fused. Very important for security assessment and disaster management. So as I mentioned to you, this is an important technology which will be required not only for defense applications, but also for civilian applications, including disaster management. Now I'll go to next one, Gaganyaan. You may have read many things about Gaganyaan in the paper, in the media, but I'll quickly go through what are the important issues, only one or two. This is the module which is on top of the rocket. The rocket takes you from Sriharikota to the orbit, but there's a service module, which is the lower level, and there's a crew module on top, inside which the Indian crew, India's first cosmonauts, will be sitting. This has got space for maximum of 3 people. 3 people can go, but finally it may be only 2 people who may be going. So this is the crew module, and there's a service module. And the service module will have solar array. It will have additional liquid propellant engines for changing some requirement in the orbit. Otherwise, it will be operating at 400 kilometers above Earth. It is expected that this module will be there for a period less than 7 days. It is designed for a maximum of 7 days. So it could be 5 days or so. And after 5 days, the plan would be to bring the Gaganyaan crew back to Earth. So the crew of 3 will be staying inside this crew module. And important aspect I will tell you, this crew module should have life support and environment control systems. I will spend a little time on that, the next slide. But that's a very important aspect, which is something new technology as far as ISRO is concerned. And the service module, as I told you, it will have solar panels and liquid propellant. So this is the crew module, which weighs about 5.3 tons. On re-entering the atmosphere, parachutes will open and this will fall into the sea, just like the same way other countries have done, USA, Russia, China, etc. have done. And will be picked up by a Russian naval ship. This is the naval ship which did the trials in October. They were able to pick up this crew module. Of course, there was no crew inside that, but they could recover this and the trials were satisfactory. Now, as we go back, we will launch from Sriharikota. It'll go to the orbit. About 5 to 6, 7 days, it'll be in the orbit. And it'll come down, open parachute, and fall in the Bay of Bengal, where the ship will pick up. So what will be the challenge? The challenge will be to make this crew module for crew to stay. That means crew should be able to breathe oxygen, and they will, of course, they'll exhale carbon dioxide. The carbon dioxide has to be removed. So you should have a system which will maintain the air inside the crew module as far it is atmosphere, just like atmosphere. 21% of carbon dioxide, some nitrogen, very little carbon dioxide, 21% oxygen, I'm sorry, very sorry, 21% oxygen, nitrogen, and some carbon dioxide. And whenever the crew exhales carbon dioxide, they should be able to remove it. That is where the challenge is. The method by which this will happen during their period of stay will have to be made. This system will have to be made. The system in a big size has already been made for nuclear submarines in India. Of course, the size is much bigger. It has to be made quite compact and put inside the crew module. Normally, what happens is there is a filter which is able to absorb the carbon dioxide. And when the carbon dioxide level is very high in that filter, another filter is put in the circuit. And the filter, which is already full of carbon dioxide, is put in an oven. And the carbon dioxide is released on heating up the filter. And that carbon dioxide is taken away to a cylinder and charged and kept there. And the filter is ready to come back. All this thing will happen automatically. And the service time for the filter to be heated and carbon dioxide be removed and bottled and cooled and ready to come back should be less than the time it takes to absorb the carbon dioxide from the room of the crew cap module. So this trial is going to be this already been tried out on our nuclear submarines, which is much, much, much bigger. So it'll have to be tried out on a smaller area with a smaller equipment, and various contingencies have to be planned in the trials. And this will be recovered once it comes back to sea by the naval ship. So I will go to the next technology, which is Samudrayan, which is being done by NIOT, the same organization which was doing sea mining. I suddenly remember now this artificial intelligence where the Prime Minister had a dialogue on the TV was with Bill Gates. It had come on the TV. Okay, Samudrayan, we'll see very clearly what is the scope. It's a sphere, titanium sphere, about 2.1 meter diameter. The shell is 25 millimeter thick because it has to go to 500 meters below the sea with 3 people inside. This is a manned underwater mission. Why are we doing this? Because once we start sea mining, our machines which are working may have some malfunction, and we have to go and see what exactly has happened. Is it broken? What type of damage has happened? So you have to send some people to the bottom of the sea who will look through these windows. It's called these glasses which are there through this portholes. Through these portholes, they'll be able to examine what is and take photograph of the equipment, our equipment which has started malfunctioning at the bottom of the sea. They'll be able to go down, attend to it, and come back. And they have only 12 hours of time to do this. So in 12 hours of time, they'll be able to complete this and come back. It is lowered into the water, to the deep waters. And the trials were conducted November 21st. It was tried up to 500 meters, successful. Now they'll be tried for higher depths. We'll go to 1,000, 2,000, 3,000, like that. We'll try up to 5,000. This is very important capability, which we have to have when we start our sea mining happening. Very often we'll have to see also whether any other equipment of some other country is operating in a particular area in our EEZ. So if you want to do some reconnaissance of that, then also you require these sort of spheres, which will be lowered from the ship, from the surface. Now I come to my last technology. As I told you, removing carbon dioxide from atmosphere is a huge challenge for the whole world. You're already feeling the effect of global warming. I'm sure every place in India, every place in the world is warmer than what it was last year. So we have to find ways and means of removing carbon dioxide from atmosphere. You all know higher level of carbon dioxide traps the heat in the atmosphere, and therefore the atmosphere is warmer, leads to melting of ice in the polar region, and it leads to leading to ice melting and sea levels going up. Whole lot of chain action takes place. So let us see how this removal of this thing is take place. There are 5 techniques. One is afforestation. Takes a long time. You have to plant a tree, it has to grow and absorb, but it's a good technique. There's a natural way of doing it. Another one is you burn the dead wood, charcoal, in controlled condition with less oxygen. If you burn it with normal level of oxygen in the atmosphere, carbon dioxide is produced. So reduce carbon dioxide by burning charcoal, and it's called biochar or bio waste. You burn it and with less oxygen, and that can be used as as fertilizer. At the same time, carbon dioxide is not released much. Then you make sure ocean fertilization happens by ensuring there are elements in the ocean which are capable of absorbing carbon dioxide and releasing oxygen, like plankton. Then there are along the coast, you have many other type of plants which grow. You have to make sure that those things are permitted to grow, and they should not be removed for doing some project on the waterfront. Then there are methods by which in the industry you remove the carbon dioxide before it is released to the oxygen, before it is released to the atmosphere. It's called capturing the carbon dioxide or sequestration of the carbon dioxide. There are also techniques by which you put minerals on in the field, on the ground, and that absorbs carbon dioxide by oxidation, and the carbon dioxide is removed from the atmosphere. But that is a little long term. So there are many techniques which have to be tried. But the most important technique which the world is trying to pursue is this. Very briefly, I'll tell you, it is capture of carbon dioxide. First of all, you should know the difference between capture, avoid, and remove. Avoid carbon dioxide means don't burn diesel, don't burn petrol, don't burn coal. You're avoiding it. That's one way of reducing carbon dioxide. The other one is you remove carbon dioxide while it is being burned through some chemical process. There are many ways it can be done. It has been tried out on board ships that the fumes are passed through an alkaline solution in a tank, and that goes through this chemical process by which carbon is removed. but that's not possible in big factories, etc. Requires huge infrastructure. So you go to capture. In capture, what happens is you, as I told you earlier, you take air from atmosphere. There's a filter inside which absorbs the carbon molecules. It's a molecular filter. It holds back the carbon molecule and only the air goes past. When this filter is choked, you remove the filter and put another filter, or automatically do this process like I talked to you about nuclear submarines. So this principle is already been there for specific applications, but not so much for uh, doing it in open atmosphere is not happened. So let me come to the conclusion of today's talk. We are going to become third largest economy. Lot of industrial advancement is required. Lot of power has to be generated. Lot of power generation means a lot of coal will have to be burned if nuclear doesn't come with all the power. So we have to make sure that our manufacturing in semiconductors as well as security levels of minerals, that is sea mining, etc., are able to consolidate in the next 5-6 years. Carbon emission has to be controlled simultaneously while we are doing all this. Artificial intelligence should help us, while data fusion will give us advantages, tactical advantages in defense and aerospace sector, apart from efficiency, enabling efficiency in disaster management. And Gaganyaan and Samudrayaan are national programs which would ensure that we are able to join the League of Nations, the big League of Nations, the powers which are been able to do all this work, and we would also join them, and we'll be at par with them, with other leading countries, when we reach the third economic power status in the country. Ladies and gentlemen, thank you very much. Jai Hind.